Okay, this is going to be an explanation of just, I guess like a whole review of what today was and kind of like what this graphic organizer is supposed to be, as well as just like going over the answer key, as well as like probably some additional problems I'll make right up the spot right now. Um, but yeah, first we have vertex form, and I think luckily all of you filled like the graphic organizer, but it's written as this. It's written as y times a times x minus h squared plus k. So in this case, we have the following. So we have to know what each of them kind of mean. So A tells us if it goes a sad face or smiley face. H tells us how left/right the parabola goes. And then K, it depends on how up or down it goes. For the vertex, we're just going to use the point HK from our vertex form, as well as our axis of symmetry is going to be x is equal to h. This is the biggest part that Miles kind of ignored, and it makes sense because it actually requires a lot of math to do this. So we just say ignore for now, and then only for factored form. For the y-intercept, it's not too hard, but basically all you have to do is plug x equals to 0 in our function. So what I mean by that is that if I have f of x is equal to a times x minus h squared plus k, all I would do is find x is 0. I'll plug that in for x. I could give an example, but we're going to go over it in the answer key. The domain for all parabolas is all real numbers. And then the range is going to be dependent on a and k. So I think you have to remember that it's both of them. And then the reason why it's dependent on both of them is because A will tell us the inequality sign. So I'll write that down. A tells us the inequality sign. And then K tells us, I guess like when like either like the starting value or like the ending value for our problem. So I'm going to say K tells us the starting, not the starting value, but I guess the I'm going to say the max / the min value for our problem. Okay, next one is going to be factor form. The factor form version is going to be a times x minus r1 times x minus r2. Not too bad. For x-intercepts, this is probably not a hard concept, but something that people kind of forget. But the x-intercept is basically x is equal to r1 and r2. And you write it like this, and you have to write it as this points, r1 comma 0 and r2 comma 0. I'm going to put a note here and say that you do have to do this. You have to do x minus r1 and x minus r2 and then solve for x. So just because you want to like flip the sign, like you see like negative r1 and you're like, oh, I see negative r1, I just want to flip it. That is like technically a more intuitive way, but it's not a very practical way because sometimes that never happens. And actually you might run into some problems if you do that. Y-intercept is going to be the same thing as what we did in vertex form, where basically you just plug x is equals to 0 in our function. So again, f of 0 is equal to ... Domain is still the same, still all real numbers. And then this is where kind of like the hard part goes in. For the domain, oops, I think it's not loading. Oh, there it is. So for the axis of symmetry, this is the hardest one. But basically, we remember that for axis of symmetry, if I have something like this with R1 and R2, my vertex is always going to be in the middle of it. So if I quote it as the middle, there must be an equation for it. And there is. It's going to be just the sum R1 plus R2 over 2. And then we'll see that in some examples in the review sheet or just on the answer key and things like that. So that's how you find it. And you always have to write x is equal to R1 plus R2 over 2. Whatever that R1 plus R2 over 2 is, that is your axis of symmetry. And you have to write it as x equals to something. Note that this is actually equal to h, because remember, in our vertex form, we said that axis of symmetry is x equals to h. And this will help us, right? So when we figure out the axis of symmetry, we can now figure out the vertex. So once we find x equals to h in our factor form, we plug in x equals to h into our function. So whatever our h value is, we just plug in f of h is equal to dot dot dot. And we'll again see that. And then the last part is the range, which we have to just say it's dependent on k, a and k again. So dependent. So this is like a brief rundown. I didn't do any examples. I didn't go too much in depth because I wanted to focus on the review. But let's go with that. Let's see this answer key and kind of like make sense of it. So here I have my answer key, and I have negative x minus 2 plus 7. I'm going to zoom in a little bit. I'm going to try to explain my answers as I go. So with seeing this, I noticed that for my vertex, what I usually do for the vertex and trying to do this stuff is try to mimic that vertex form that I wrote. So I knew that my vertex form formula is a times x minus h plus k. And if I remember correctly, what you can do as a trick is that you see that negative 2 and you flip it. So what I'm going to say is that you flip the negative 2. So that implies that h will equal to 2. And then the way you get 7 is that you see the 7 right there. So that's how I got h is equal to k equals to 7. Okay, so and then the last thing I want to figure out is what a is. And I figured out that a is equal to negative 1 because I see here there's a negative sign right here. And I know, oops, I know that I can just put a negative 1 right there. Oh my gosh. I can put a negative 1 right here. And so now I have my 3 values. And what I'm going to do next is try to figure out the rest. So I know what my axis of symmetry is. I said that x equals to h. And then I basically know my h value, which is 2. So I say that x is equal to 2 for my axis of symmetry. Nothing fancy there. I just figured out what h was. Y-intercept, I said you have to plug in 0 for x. So notice I wrote f of 0 is equal to, and then notice I just replace my x value with 0. So then I put 0 minus 2 squared plus 7. I figured out what 0 minus 2 is. That's negative 2. Negative 2 squared is 4. But there's a negative sign in front right here. So then I added with that 7. Negative 4 plus 7 is just me saying 7 minus 4, which is 3. So I figured out my y value. And remember, you always have to write the y-intercept as like a point. Like if you wrote like the y-intercept is 3, I kind of know what you're saying, but I want you to be really specific because 3 can mean a lot of things. But if you say the y-intercept is a point, you're good to go. With that being said, we can focus on the new things. Domain is all real numbers, as I said before. And then range. So I'm going to look at the reasons as to why I wrote this number. So I know that my range is dependent on a and k. So since my a is negative 1, I know it's going to go downwards. It's going to have like this sad face. And I know my k value is going to be 7. Since my since my A value is going to be negative, what I can do is that I can look at that vertex, that 2, 7, and I know that since it's going down, it's going to be less than. So that's why when it's less than, it's going to be when A is negative. So again, when A is less than 0, you're always going to have f of x is less than or equal to k, while A is greater than 0, we'll always have f of x is greater than or equal to k. That's something to keep in mind. With this, I basically then plotted it. I used the 1, 3, 5 rule. So I plugged in 1. I see that this is going to 1, this is going to 1. I notice that as this goes to 1, this should go to 3. And then lastly, as this goes to 1, this should go to 5. And then you do the same thing for the left side. With this, we can move on to 2. It says write an equation in any form that is translated left 2, down 1, vertically stretched by a factor of 1. So that's a lot of words, and definitely it's kind of hard to figure out. But one thing that you can do is that you have to translate these words into values, right? So I have to figure out what left 2, down 1, vertically stretched means, and how this relates to the vertex form, because if it talks about this, it basically wants vertex form. So if I say left 2, that's to relate to h. If I say down 1, that relates to k. And then vertical stretch means that I have to relate to a. If it's left 2, what I'm going to do is that I'm going to think that if it's left, I'm going to put a plus sign. And if I think down 1, I'm going to imagine it exactly what it is. Down 1 means it's less. So I'm going to put a negative sign. If I did say like something like right 3, that would be x minus 3 squared. If I said up 4, that would be x squared plus 4. That's something to keep in mind. And then lastly, the vertically stretched by a factor of 1. The reason why it's 1 is because since it says it right here, all I have to do is plug it in for a. So that's the equation. Nothing too special here. I feel like the hardest thing about this question is the left 2. I've seen a lot of people kind of get confused by that. They kind of like think the reverse of it and then think the reverse of the reverse and then kind of like undo it. So basically you think of it like this. If it's going to be left of something, you know you're going to have x plus blank. If you know it's going to be to the right of something, you know that's going to be x minus something squared. So that's something to keep in mind. You can put in your organizer or something. If it's going to be down something, so like down blank, you're going to have x squared minus blank. If you have up something, you have x squared plus blank. So let's see this in action. This is with part B. Write a quadratic equation that's reflected over the x-axis and is translated right 5. So I see right 5. And I see right, okay, if it's right 5, I'm going to write right 5 here and match it up here. So that's how I got x minus 5 squared. But then how did I get this negative sign in front? Well, that's with this part, reflected over the y-axis. I know that we didn't really talk about how these quote-unquote transformations work, how they basically move left to right, up and down, reflect. But basically, reflecting over x-axis is this. You have a parabola that looks like a U right here. And if you're reflecting it, you're basically going from U to like an upside to a sad face, right? So it's going to look something like this. And I'm going to write it in gray. Oops. Here it is in gray. It would look something like this. And then if I notice this is going to be y is equal to x squared. But then this one's going to be negative x squared. So knowing that, what changed? And what really changed was the a value. It turned from +1 to -1. So that's what I'm going to do for B, and then that's how I got my answer. C is which of them affects range, and I mentioned it before in part E, and a little bit in the graphic organizer, but it's going to be A and K. well, which affects the domain, it's going to be none of them since all parabolas have all real numbers as their domain. I'll explain this one. But I'm not going to explain most of the review because actually we'll see. We'll see how I feel. For this one, I have to do is find the x-intercepts. So you notice here that what I did was I ignored the 2. So I kind of basically ignored that like it never happened. Like imagine me erasing it like that. And then I set when these two things, these two things multiplied together, when those equal to 0. So what I did is, as you can see here, I put x minus 1 is equal to 0, and I solve for that. And when x plus 3 equals to 0, and I solve for that. So in order for you guys to do that, and as a recollection of what Algebra 1 taught you, what you have to do is you have to move from, you want x to be alone, but you see -1 is on the left side. So what you do is that you move it to the right side by adding 1. The 1's cancel, get x along the left side, that's good. And then you have 0 plus 1, so that's going to be 1. And then the same thing happens for x plus 3. So for x plus 3 equals to 0, you have plus 3, so you have to do the reverse if you want to move it to the right side. You cancel them, 3 minus 3. So that's x, and then 0 minus 3 is -3. So yeah, notice what I did with that. I found out what my x values are, but I'm not done because I have to write it as a point. X-intercepts is basically when it hits the y-axis. And in order for me to hit it when it's on the y-axis, so I have to remember that if it hits the x-axis, I have to have my y value being 0. So that's what that is. Axis of symmetry. This is the hardest part. Since I know that my vertex is going to be in the middle, what I have to do is take the average of the 2. So you notice here, and this is kind of small work, but what I did was I took the average of it by adding the 2. So 1 plus -3, so that's 1 minus 3. I figured that math out, so that's -2. I divided that by 2 because it's the average, the middle of it, and I get -1. So my axis of symmetry is x equals to -1. Now that I know that this is my h value, I have to remember like this idea of a vertex form. And since h is equal to -1, what I'm going to do is that I'm going to plug it into my original function and figure out what my k value is. So remember, yeah, with that vertex form, you have that equation, a times x minus h squared plus k. And then what I have to do next is then I have to plug in what my h value is and then see what my k value is in this equation. So as you can see for part C, I put f of -1 is equal to -2 times -1 minus 1 times -1 plus 3. So that's going to be -2 times -2 times 2, right? -1 minus 1 is -2, -1 plus 3 is 2. So that's how I figured it out. Y-intercept is the same idea, but instead of plugging in -1, you plug in 0, and then that is my following work right there. 0 minus 1 is -1, 0 plus 3 is 3. I multiplied all of those out. You got 0, 6. My domain, always all real numbers. And then I come back to this, and I see that it's negative. So since it's negative, I'm always going to have this form. The f of x is less than or equal to k. Now I have to think about what my k value is. And I found that with my vertex. I plugged in what that h value is to get my y value. That is my k value. So I'm going to say it's equal to k. I plugged it in, and I get f of x is less than 8. Not too bad. I then graphed it using the 135 rule. So right here is going to be -1, 8. And then basically what you do, you have to go down to 6 and then 10. So how did I get that? I multiplied 2 times 1, 3, 5. I know I write it weird, but that's basically how I kind of illustrate it. But what you do is that as you multiply these, you see what you get. So 2 times 1 is 2, 2 times 3 is 6, and 2 times 5 is 8. And I notice I'm going down, so I know that for every increase in x, I go down 2. For another increase in x, I go down 6, according to this rule. And every time I increase x, I go down 10. So that's basically what that is. And then can move on. 4a talks about like your x-intercepts at x minus 1 and x minus 7, or x equals to 7. So how I got this is that I know that since it's x equals to 7, what I can do actually as one idea is that if I have x minus 7, what I can do is kind of like do the reverse of that. I want the other side to be 0, but I want to leave this left side as like a new factor. So what I'm going to do is that since 7 is on the right side, I can move it to the left again by subtracting by 7. So then with that, I basically got that x minus 7 equals to 0, which is what I get as one of my factors. And then I do the same thing when it comes to x plus 1, right? I have x equals to negative 1, but if I wanted to move it to the left side, I can just add 1 to both sides. I don't think my screen is loading, so I'll try to do that again. Let's load that again. But yeah, that's basically how you kind of figure out like the quadratic equation in like factor form. And then if I keep on talking to write an equation that has x-intercepts of negative 10 and 2, you do the same thing. You see x is equal to negative 10. So what you do is you kind of add 10 to both sides. So you get x plus 10 is equal to 0, which you see right here. And then x equals to 2, you can just move that 2 from the right side to the left side to get x minus 2 is equal to 0. I see. Okay. Hopefully it loads again. If not, I'll just stop here and then we'll continue on. So it's back. So yeah, I talked about like the x minus 10 and then x equals to 2. So I kind of do the opposite. So I say x equals to negative 10. What I do is add 10 to both sides. That becomes 0, and now that becomes x plus 10. And I kind of want this equals to 0, because then I know that I'm doing the factor form right. The same thing happens when I do x equals to 2. I take x equals to 2, I subtract by 2, so I get x minus 2 is equal to 0. So you always, if it says like something is equal to 0, that means it is the factor, and I can't put that in my factored form. So that's how I got x plus 10 times x minus 2. And then the vertically dilated by a factor of form we kind of talked about in the first page. And then with that one, you're basically just thinking about how if it's vertically, I think I mentioned it somewhere here, but like vertically, it has to relate with A. So I know that since it's going by vertically dilated by a factor of 4, I know that my A value is going to be equal to 4. I'm probably not gonna go over this one because I feel like, and like the rest of these graphs, because they're kind of like repetitive. So I'll probably make a new one. But I will go over probably like the parent function one, because I feel like a lot of people had questions on that. So for the parent function, what is the secret values of A, H, and K? So what I'm gonna do is that I'm gonna write my vertex form. And I'm basically trying to just get y is equal to x squared. Now, what I did was I drew a lovely graph right there. That kind of tells me a little bit more about y equals to x squared. How I got that graph is either I just remember it from memory or I just plug in points, right? Like 0, 0, 1, 1, 2, 4. It keeps on going. But what I'm ultimately seeing is that my vertex is 0, 0. So I know what that is, and I can basically tell that from the graph. But I know that for my vertex form, that for vertex, it's just going to be h and k. So if I already know that my h and k and my vertex is going to equal to 0, 0, then I know what my h and k values are. My h is 0, my k is 0. And the last thing is that I'm looking at this and I'm like, wait a minute, it doesn't actually say anything about a number, right? There's no number in front of x squared. So I know that that's going to be like the imaginary 1. normally they actually just do tell me, like they tell me if it's like either 2x squared, 3x squared, it keeps on going. But this one they just said x squared. So I know it has to be that invisible 1. So I know that a has to equal to 1. And I gave you guys a little bit of an explanation too. I said since the f of x, and I basically plugged in a, h, and k, I plugged all those in and I tried to solve it, it results in x squared. So that's what the vertex is of the parent function. And then the last thing I did was talk about the axis of symmetry. We luckily talked about how the axis of symmetry only relates to the h value. And since the h value is just going to equal to 0, x equals to 0 is going to be our axis of symmetry. And we can see that here. That's going to be x is equal to 0. Again, not going to talk about number 6, but number 7 is going to be kind of the same thing that I talked about with the factored form in number 4. But basically, you make these two factors, the 3x minus 1 and the 7x plus 5 equal to 0, and you solve for that. So I have here for 3x minus 1, what I did is I wanted to move the negative 1 to the right side. So what I did was I added 1. What that does is that it cancels the 1s, at least 3x is equal to 1. I wanted to just have x alone. I don't want to have that 3. So what I do is that I know that it's going to be 3 times x is equal to 1. So instead of multiplying, what I'm going to do is reverse. And this is how you solve equations. What you do is that you do the reverse by dividing by 3. So that's how I got 1/3. Same thing with the 7x plus 5. I see plus 5. I do the opposite. That's subtracting 5. So I get 7x is equal to negative 5. I have 7 times x is equal to negative 5. So what I'm going to do is divide by 7. And I get x is equal to negative 5/7. So that's what I have. 8. I feel like this is a good, important one, but sketch a graph of a parabola that has no x-intercepts. So you have to remember what the concept of an x-intercept is. But basically, it's just when the parabola hits x-axis. As you can see from my example, it doesn't touch the x-axis at all. I can draw something like this. I can draw something like this. Whatever I did, those are not touching the x-axis, which is good. And I think for this one, you have to remember, when is a parabola having one x-intercept? Or when does it have two? I think sketching a graph for those is pretty helpful. The additional practice is the same thing as vertex form. That's fine. And then the last one for number 6 is the exact same as what we did in this one right here, number 7. So that's basically all the review. What I'm going to try to do, I guess, is that I can, let's see if I can add a current page. Okay, I can. Let's say I just created a graph and a function as another review. And then this will be, I'll just give them 2 examples. One of them will be a vertex. The other one will be a factored form. So here's my grid. And then let's say I told you guys to calculate the function. Why the heck not? Y is equal to negative 2 times x plus 1 squared plus 4. And I asked you like the same things to figure out whether it's like the axis of symmetry, vertex form, domain and range, y-intercept, all that all that random stuff. So yeah, I think the first thing you want to do is that you want to just identify your values. So A, H, and K. So what I'm going to do is I'm going to say A times x minus h squared plus K. So I know my K is just visibly there. I don't have to flip those signs. So I know that K is equal to 4. A is the same thing. I just look at it. See, it's just negative 2. So A equals to negative 2. And then H is the one that I do flip. So I notice that since it says plus 1, what I'm going to do is that I'm going to say flip plus 1, which means it's equal to negative 1. So I know what my H, A, H, and K is. If I had to say the line of symmetry then, I know my line of symmetry is going to be x equals to h, or negative 1. I know that my vertex from my graphic organizer, I know that's going to be h comma k. So that's going to be negative 1, 4. Now that I know my line of symmetry and vertex, hey, why the heck not? Let's figure out the y-intercept. That's when x equals to 0. So I'm going to plug it in. F of 0 is equal to -2 times, now I'm going to replace x with 0. 0 plus 1 squared plus 4. That equals to -2 times 1 squared plus 4. 0 plus 1 is 1. So I'm going to say 1 squared is 1 plus 4. -2 times 1 is -2 plus 4, which is equal to 2. So therefore, my y-intercept is going to be 0, 2. I can't figure out the x-intercept because it's in vertex form, but I can tell a little bit more about domain. My domain is all real numbers. Then what about my range? And this is like the hard part of vertex form. I'm going to look at my a value. So I'm going to say since a is equal to -2, I have to remember what happens when a is less than 0. When a is less than 0, it looks something like this. And it looks like all the y values are going to be going down. So I know that my range has to be something in the form of y is less than or equal to k. Since k is equal to 4, I can just basically say that y is less than 4. And it has to be less than or equal to, because it's a parabola. This is where I'm going to draw the graph. So here's -1, 1, 2, 3, 4. So -1, 4. My my y-intercept is 0, 2. I'm going to do the same thing here because of the line of symmetry. Now I'm going to think about that rule. How do I draw the other 2 points, right? Because I'm going to try to draw at least 5 accurate points. So since I have that 1, 3, 5 pattern, so what I'm going to do is that I'm going to multiply that 1, 3, 5 pattern to get the following. I get 2, 6, and 10. So what I'm going to do is that for every increase in 1, I'm going to go down 2. So that's that. That's the first one. But then if I increase it by 1 again, I decrease it by 6. So 1, 2, 3, 4, 5, 6. And I do the same thing for this. So I'm going to draw it like this. I could draw the line of symmetry, but all I asked was just to draw the parabola. So it looks something like this. And that's basically it. Not too bad. I feel like where people will trip up is probably the y-intercept and this range. So the range, you have to remember, involves this k value. And also, I think maybe sometimes the line of symmetry or the vertex. Sometimes the vertex people get tripped up by just because sometimes they flip the h and then they forget the k. And sometimes for range, they just look at the y-intercept and they're like, oh, it's 2. I'm going to put that as my range. My y-intercept is not the range. It's just the y-intercept. Let's do one last example. Y equals to actually we'll do +3 times x minus 1 times x minus 3. And I'm asked to do the same thing, but this time I'm going to ask for the x-intercepts. And that's actually the first thing I'm going to ask. It is my x-intercepts. So again, what I have to do is I have to say y is equal to a times x minus r1 times x minus r2. This is the factored form. What I do with the vector form is that I kind of match it up with my original equation. A is equal to 3, it's right here. But what I do for r1 and r2 is that I basically ignore 3. What I'm going to do is that I'm going to then again make it equal to 0. So I'm going to make this x minus 1 and x minus 3 equal to 0. So I'm going to say let's x minus 1 equal to 0 and x minus 3 equal to 0. The reason why I make these equal to 0 is because anything times 0 gives me 0, which is what I want for my x-intercepts. I want y to be 0. So again, yeah, let x minus 1 equal to 0 and x minus 3 to equal to 0 to have y equal to 0. So what I'm going to do is I'm going to solve it. X minus 1 is equal to 0. I'm going to move the +1 to both sides. Those cancel, and I get that 0 plus 1 is equal to 1. And then I'm going to have x minus 3 equal to 0. I'm gonna add 3 to both sides and have x alone. Now I see that I cancel out the -3 and 3. And lastly, I do 0 plus 3, which is 3. So therefore, my x-intercept is 1, 0, and 3, 0. Not too bad. What I then do is I have to now figure out my line of symmetry. So in this case, I know that it has to be in the form of x equals to h. But I'm not given h, I'm only given my roots. So what I have to then do is that I have to remember the other equation. I said take the average, or the middle between 1 and 3. So I'm going to say r1 plus r2, so that's going to be 1 plus 3. That is going to equal to 4 over 2, which is 2. So I know that this is equal to h. So h is equal to 2. That's great, but what does that help us with? Well, say I now ask for the vertex. And I know that the vertex is going to be equal to h of k. Well, now that I know that my h value is, now it's going to be 2 comma k. I'm done. Just kidding, right? Because I had to figure out what my k value is. So in that case, what I'm going to do is that I'm going to plug in when x equals to 2. So that's going to be y is equal to 3 times 2 minus 1 times 2 minus 3. So I just replace the x with a 2. And then I solve the math. 2 minus 1 is just 1. 2 minus 3 is -1. 3 times 1 is 3 times -1. That's just equal to -3. So then therefore, that's equal to my k value. So I know my vertex form is going to be 2, -3. What does that tell us? Well, that tells us a little bit more about something. But first, before I actually tell about what that does, let's figure out that y-intercept. And that's basically when, again, x equals to 0, much like what we did in the last problem, when we figured out the y-intercept. When x equals to 0, basically, we're going to plug it in. So we're going to have y is equal to 3 times 0 minus 1 times 0 minus 3. 3 times 0 minus 1 is -1. 0 minus 3 is equal to -3. 3 times -1 is -3 times -3. -3 times -3 is plus 3 times 3 is 9. So my point is 0, 9. Last thing I have to figure out is my domain. That's all real numbers. And then the range. So I have to remember what my a value is. My a value is 3. So since my a value is 3, I know that's going to go positive, so it looks like this. And I know that for my vertex, I start there and I go up. So I know that my range should be something with greater than or equal to, since a is greater than 1. Sorry, greater than 0. So I know that so that my range is going to be y is greater than or equal to k. How do I find k? Well, I already found it, right? Because I said that k is equal to -3. So my answer for my range is going to be y is greater than or equal to 3. Okay, now I plot it. I plot all the information that I have into my graph. -1, -3. And then what I have to do is I have to plug it in my vertex. Oops, I'm at 1, 3, not this. So I have it at 1, 0, 3, 0, and 2, -3. I notice here that I have a 3, so how am I going to point the other ones? Is that I'm going to use 3 times that 1, 3, 5 pattern. So I know I have to have 3, comma 9, 3 times 3. 3 times 5 is 15. So I moved it up 3. So right, I moved it here 1, moved it up 3. Then I have to do it by 9. So move it by 1 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. I do the same thing here, but it's kind of going out of bounds. So what I'm going to do is that I'm just going to try my best to graph it. And something like that. And that's it. So not too complicated. I feel like if you do a lot of repetitions, you'll basically be pretty much good to go. But yeah, that's all I have for you guys. Hope you guys ace the quiz. And again, you're going to always ask us more questions during office hours. See ya. Peace.